All right, so you can see my screen here. I think, let's see, how many of you did not do your work? Javier, you did your work. Jocelyn, you must be very busy, right, recently? Yeah. It's okay, don't worry. Then we go through together. Yeah, lor. Too many exams. I know. Because my daughter also going through a lot of exam. Okay, I told you all right, my daughter in Sec 3, my son in Sec 1. Yeah, everybody's having exams, so it's fine. Yeah, okay, Javier, no problem. Javier, no problem. Okay, Javier is shy to turn on the camera. Okay, Brayden, you have to keep your camera on, Yeah? Okay, good. So let's see. These questions is on electricity. I will be slowly going through. All right. So we have already gone through the lesson on the electricity. All right. But let me show you something first. So for you, Brayden, okay, just a minute. Okay, there is this particular app that later I'll send you the link. Okay, it's on the construction of electrical circuit. Okay, so today we take it easier because a lot of you, I know you're having exams. Okay, have you all completed the exams in school? Jocelyn? Okay, Brayden finished. Javier just finished, so must be very tired, right? Need the rest. Understand? Because why? My Sec 2 students were so quiet the last time. They totally have no energy to do it. Yeah. Okay. Heng, Jocelyn. Luckily, you finish 2 minutes before. You're not afraid, is it? Because if your internet connection is weak or the Wi-Fi gives you a problem, you cannot submit on time, no? Wow, I salute you. You're so brave. For me, I will be scared to death if I have to submit 2 minutes before. Struggle, man. Okay, Sherman is here finally. Good. So, Brayden, Javier, Jocelyn, and Sherman, they are the permanent students for our class. Yeah, very small class. Small is good also. All right, so let's look at this particular question. Water circuit is used as an analogy to an electric circuit. Okay, so let me just ask you, all of you, do you still recall you have done electricity in primary school? Yeah? Yes, right? Do you remember you did the series circuit, parallel circuit? Yes, right? So you recall all this. Good. Now, it's important that you can still recall because if you do not, you have to let me know. Then I can see how I can help you by, maybe preparing certain, hold on, let me just see, certain slides, okay, for you. Now, because I might want to give you some notes first. Hold on. Okay, on electricity. So perhaps maybe I don't do the worksheet first. Let me just go through some slides. Can go through some slides with you. Can you see my new slides now? Okay, please do not take picture or anything, Brayden. Don't try to copy notes. Don't try to take picture. I will be sending this to you. Pay attention first. Okay, because if you are copying, you can't listen well. So electricity, you have to know at secondary school level, what is the meaning of current, what is potential difference, what is resistance, and you also need to state the units. Okay, then you must learn how to draw and interpret circuit diagram. All right, set up circuits containing electrical sources. Electrical sources means batteries, Okay, it can mean that you have the current from the mains. So that's the meaning of electrical sources. Mostly we just draw batteries. And then you're going to learn something about batteries later. Switches, you must know. There should be a comma here. Then lamps are like the light bulbs. Resistors, ammeters, and voltmeters. So what are ammeters, what are voltmeters? You will also be learning in this chapter. Then recognize that resistance of a circuit can be varied by arranging resistors either in parallel or in series. Explain, chemical, heating, and magnetic effect. I think you already know electricity can bring about chemical effect, electrolysis, remember? Then bring about heating as well, okay? Because we need to turn on the electricity in order to get the iron working, the oven working. So they bring about heating effect also. What about magnetic effect? Still recall? In primary school, we did this? Correct not? You remember there's these iron bar, then there's the wire going round it. Correct not? Did you do that in the science lab? You did. Good. Yes, that's called electromagnet. So there is also magnetic effect being brought about by electric current. So we need to list application, okay, related to electricity. And then investigate the effect of varying resistance on the current in the circuit using fixed or variable resistor. So variable resistor, it helps us in the sense that you have seen certain homes with the lights being able to be adjusted, either dimmer or brighter. Yes or no? You turn the knob, it will become brighter. Okay, you turn the other direction, it becomes dimmer. Okay, so this is being controlled using the variable resistor. We will learn more about it later. Okay, so these are some of the things that you will see in the science lab. So what's current? You need to define current. It is actually the rate of flow of charged particles. All right, and then it is the measure of the amount of charges flowing through at any point in a closed loop at any unit in time. Okay, hold on. I just want to find this link to send to you the notes. Okay, let's see. Yes, it's here. Now, take a look at the chat. I am sending the link now. You can go and once you go to this link, right? Click on it. Once you go to this link, right? Okay. Okay, everybody go and click on this thing and then tell me whether you can see the flip book. Okay, can see, yeah? So if I share with you the flip book, you should have something like that, right? Then, yeah, you can flip it. All right, so this is what you're going to see. This is what you have for your notes now for this topic. Okay, so because I don't keep this flip book for too long, what you have to do now is, can you go to the bottom? Can you see the PDF? Download PDF. Can you click on that to download this? Save a copy for yourself. Okay, because this flip book, the link will be removed like in 1 or 2 weeks. Everyone downloaded? Okay. Braden, can you download? Do you know where to download, Braden? Okay. Are you looking at my screen now? Can you see where my mouse is pointing? At the bottom? My mouse is here. You unmute yourself. The rest of you, did you manage to download?
Hang on first.
Yeah.
Okay, yeah.
Okay, you see these are download PDF, you click on it. Then they will you will show this thing, right? And then you go to save. After you go to save, right, then they will let you choose where you want to save it. Can you do that? Yeah, everybody, you got to do it. So you can keep a copy, because once the link is deleted, you can't access that flipbook anymore. Okay. So if you are looking at your notes and then you are looking at my slides, okay, they are exactly the same thing. So don't worry about missing out anything. Unless I am writing on the slides, then you should be copying. So what you study now is the charged particles moving are the electrons. Therefore, current refers to the flow of electrons in the circuit. Okay, one single electron actually carry a very small charge, 1.6 times 10 to the power minus 19 coulomb. Okay, so this is how electrons are flowing inside the circuit. And then I'm going to show you, all right? Okay, you see this? If more charges flow through the circuit per unit time, a greater amount of current will be detected at any point in the circuit. Okay, mathematically, this is calculated this way. The charge can be calculated this way. You multiply current by time. Now, so conventional current versus electron flow. I'm going to show you also using the application called FET. Okay, where is my FET? That is here. So I'm going to show you this application to tell you about the movement of conventional current and electron flow. Not to worry, I'll be sharing with you this link also. Can you see my blue screen with wire, batteries, etc.? Okay, this application is very useful. How many of you have actually seen this before? Very good. Okay, that means you have tried this as well, right? So you put the battery in connection, right? Then I can have my switch. Then I will join nicely. Once I close the switch, okay, this is a complete path. This is how current flows. But if I talk about electrons are moving in the opposite direction. Can you see that? So this is showing you, okay, that conventional current flows in one direction, but electrons flows in the opposite. So that's what you see, okay, in the slides also. So can you see this now? Different direction, the way they are flowing. Look at the terminal. It is very important for you to take note of the terminal. How does electron flow? It flows from the negative terminal throughout the circuit and then goes back to the positive terminal. Do you still recall how to draw circuit symbols? Yes or not? Okay, you have to draw symbol. This is the symbol for the battery. The longer line represents the positive terminal. The shorter line is the negative terminal. Can you recall? Can recall? Let me know. Yes, good. Yes, wonderful. So if you don't recall, you have to tell me. Okay, now. The electric cell, this is the electric cell, okay? From now on, you cannot talk about batteries anymore. Why? This one piece of battery we usually call it, right? Okay, is known as an electric cell or dry cell. Clear? One dry cell makes one battery. two dry cells like this.